Okay, now let's complete the other half of the problems that we did in class today. First, we have y is less than 2/3 x plus 1. So we're going to start with plotting our y-intercept being 0, 1. Next, we're going to recognize that our slope is positive 2/3. So we're going to go up 2 and right 3. Or we can go down 2 and left 3. And you can continue that pattern and plot more points to make your line as accurate as possible. But you should be using a straight edge, so you should be okay. Generally, you should be plotting at least 3 points when doing any type of graph. Now, we're going to do our graph, which is going to be dashed and not solid in this case, because it's just less than. It's not equal to, so the line is not going to be solid. We're going to use a dashed line. Now we need to determine where we're going to shade. Because it's less than, we will shade below. Now, let's take a look at y equals the opposite, or negative, times the absolute value of x minus 2 plus 3. So we have the graph opening down because of the negative. We're going to be going right 2 because of the minus 2. And we're going to be going up 3 because of the plus 3. So we're going to start at positive 2, positive 3. Now it's equal, so it's going to be a solid graph, but with no shading because it's an equation. So there's no number there, so our slope's understood to be 1. So from our vertex, we can go down 1 and right and left 1. And continue that pattern. Again, you should be plotting at least 3 points. Now we're ready to draw our graph. And we are done. Again, because it's in the equation, there is no shading. Now let's graph y is greater than or equal to negative 3 times the absolute value of x minus 2. So again, this graph is going to open down because of the negative, but it's going to have a slope of 3. The graph again will be solid because it is equal to. So we're going to start at positive 2, because this is saying going right 2, positive 2, 0. So from there, we can go down 3 and right and left 1. So the graph is going to be solid. Made a mistake here. Draw the graph. Now we need to determine where we're going to shade. Because it's greater than, that means we will be shading above. So we're going to be shading this outside area. It's very important, again, that you're plotting at least 3 points, preferably as many as you can, but also that you're using a straight edge so that your graph is accurate. Accuracy is important. Now, let's graph y equals -1 times the square root of x minus 1 plus 2. So again, the negative means it's going to be reflected across the x-axis. The minus 1 is going to have us going right 1 and up 2 with plus 2. But first, let's just plot the points of our parent graph so we can see the transformation. So our parent graph, we have 0, 0, 1, 1, 4, 2, and 9, 3. So the reflection is going to have this point go here, that point go there, because it's plus 2, now it's -2, and now it's going to be -3. That's the reflection. Now we need to move all our points right 1 and up 2. So right 1, up 2. Right 1, up 2. Right 1, up 2. Right 1, up 2. So now here's our graph. So if we were asked for our domain and range, the domain is going to be from +1 with a bracket to infinity. The range is going to be from -infinity with the top being +2 with a bracket. Okay, now let's graph y is equal to the cube root of x plus 3. So I've already plotted the points for our parent graph of y equals the cube root of x. Okay, so we have our 3 critical points, beginning with the origin, 1, 1, and -1, -1. So the transformation for this graph is to simply move each of the points up 3. 1, 2, 3, 1, 2, 3, 3. So now we can draw our graph. In graphing cubes, the most important points that we'll be looking for when you do your graphs by hand are your critical points. Okay, of having to go left 8 or right 8, that gets a little tough depending upon the plane that you're given. So the most important points that you need to make sure you plot on your graphs are those 3 critical points. Okay, let's graph y is equal to -3 times the square root of x plus 2. Again, I've plotted the points for our parent graph. We're now just going to do the transformation. So with the negative, we know instead of opening up, it's going to open down. So this being in the origin, that would stay, that's up 1, so now it's down 1, it's up 2, so now it's down 2, and this one's down 3. That's the reflection upon the x-axis. Now with the stretch of 3, we're going to take their distance from the x-axis and multiply that by a factor of 3. So with this being 1, from the x-axis, 1 times 3 is 3. So we're going to bring this down to -3. this being a -2. -2 times 3 is going to give me -6. Now that will be here, and -3 times 3 is -9. So now this point is here. Now if we look at the +2, we're going to bring all the points up 2. So 1, 2, 1, 2, 1, 2, 1, 2. So here is our graph. So if we were asked about the domain and range, again, the domain is going to be from 0 with the bracket to infinity. The range would be from -infinity with parentheses, with the top being 2 with the bracket. If you would like additional practice or have additional questions, you can refer to pages 107 through 119 for assistance with the absolute value equations and inequalities, and that's sections 2.7 and 2.8 in your textbook. And for square and cube roots, that is section 6.8, which is pages 414 through 419. Again, use the resources in your online textbook also if necessary.